Assalamualaikum and greetings. So hi, my name is Safi. I and my teams will presenting to you about solving the question on subnetting IPv4 addressing by using packet transfer. So as for your information, we are from UITM University Technology Mara Campus Jasin. So before we going into the question and solve it, I will introduce our team members first. So our team members consist of 5 members. First of all, of course, me. I am myself, Muhammad Afiq bin Muhammad Halim. This is our ID as a UITM student. So Muhammad Akim Shah bin Azhar Shah, Muhammad Haziq bin Hishamuddin, Nur Muhammad Daniel bin Shafi, and also Muhammad Daniel Ashraf bin Shamsataria. So the objective of this presentation or to solve this question is to understand how to build and set up in Cisco Packet Transfer. You also will know how to create and choose the suitable prefix and subnet mask of the network, and you also can analyze the problem and solve it via the problem that have you analyze it. So without further ado, let's solve the questions. So thus I've given the background or the scenario for this question. In this activity based on topology given in figure 1, you will subnet the customer network into multiple subnets. The subnet scheme should be based on the number of the host computers net required in each subnet, as well as other network consideration like future network host expansion. After you have created a subnetting scheme and complete the table by filling in the missing host and interface IP addresses, you will configure the host PCs, switches, and router interfaces. After the network devices and host PCs have been configured, you will use the ping command to test for the network connectivity. So here is the figure 1, the topology for the packet transfer subnet on IPv4 network. So let's go to the part 1. So in this scenario, you are a technician. You need to install a new network for a customer. You are the technician. So you must create multiple subnets out of 192.168.0.0/24 network addresses, space to meet the following requirement. So you have LAN A network, minimum of 50 host IP addresses. You have LAN B network, minimum of 40 host IP addresses, and also you need at least 2 additional unused subnets for future network expansion. So the line of the subnet will not be used. All the device subnet should be the same length. So let's answer the question. So the first question, how many host addresses are needed in the largest required subnet? So you can see in here that 50 hosts are the largest required subnet. So therefore, 50 is the largest. So B, what is the minimum number of subnet required? So the requirements stated above specify 2 company networks. We have 2 company networks, LAN A and LAN B, and also you have also 2 additional unused subnet for future network expansion. That's stated in the question. This at least 2 additional unused subnet for future network expansion. So 2 plus 2 is 4, the minimum of 4 network. C, the network that you are tasked to subnet is 192.168.0.0/24. So over 24 subnet mask in binary. So over 24 subnet mask is 255.255.255.0. So 255 in binary is 1111111. And 000 is a 0. So E, the subnet mask is made up of 2 portions, the network portion and the host portion. This is represented in the binary by the 1 and the 0s in the subnet mask. So in the network mask, what the 1 represent? So this one represent the network portion. So the 0 is the represent host portions. So all right, for the next question. Given each of the possible subnet masks depicted in the following binary format, how many subnets and how many hosts are created in each example? So remember that the number of host bits to the power of 2 defines the number of hosts per subnet minus 2. And the number of subnet bits to the power of 2 defines the number of subnet. So the subnet bits shown in bold, this is the subnet bits. Shown in bold, the bits that have been borrowed beyond the original network of mask of 24. So mask of 24 is the original mask. So the prefix notation and correspondence to a dotted decimal mask of 255, 255, 255.0. All right, for the first question, it is given, the bold one is the subnet bits. So decimal subnet mask equivalent to 255, 255, 255.2e is the equivalent for the subnet mask 25. So the number of subnets is 2 power of 1. We get it. 1 is the subnet bits. So there's only one subnet bits in here. So 2 is our binary. 2 power of 1 is equal to 2, and 2 power of 7. 7 is our host in here, is a 0. We have 7 O's in here. So 2 power of 7 is 128. Minus it by 2. Host per subnet by minus 2. So minus 2 is equal to 126 host per subnet. So next question is over 26. So 255, 255, 255.92 is the equivalent for this mask subnet. So in here we have 2 subnet, 2, 1, so 4 subnet, 2 power of 2 because of 2, 1 in here, and 2 power of 6 because 6, 0, 6 hosts in here, so 64 hosts, minus by 2 to get a per subnet, so 62 hosts per subnet, the answers. So number 3, over 27. So 27 is the new mask equivalent to 255, 255, 255, 224. So we know that the bold is the subnet bits. So the subnet bits in here is have a 3 subnet bits, 3, 1, and the host is 5 O's. So the subnet is 2 power of 3. We get 3 because of there's 3 bits in here. So 2 power of 3 equal to 8, and 32 hosts we can get because of 2 power of 5, 50 in here. So minus it by 2 to get the per subnet. So we get the 30 hosts per subnet. So 28 is 255, 255, 255, 240. We have 4 bits of subnet and 4 hosts. So 16 subnets is from 2 power of 4. 2 is binary. 2 is a binary, remember that. And power of 4 is the 4, 1 in here. So 16 hosts get by 2 power of 4, 4 zeros, minus it by 2 because to make per subnet, to define the number of hosts per subnet, we minus it with 2. So because of that, we get 14 per subnet. So next one is over 29. We get over 29 for the mask equivalent. For this over 29 is 255, 255, 255, 248. So we in here they have 2, 4, and 6 subnet bits in here. So 32 subnet we can get because of 2 power of 5, and 8 hosts because of 2 power of 3, 3 hosts in here. So 2 power of 3 minus 2 because of we want the per subnet, so 6 hosts per subnet. So number 6, over 30. Over 30 is we equivalent to 255, 255, 255, 252. So 252, the number of the subnet is 64 because we 2 power of 6 is equal to 64. And 4 hosts because 2 power of the 2. So minus it by 2 to get a host per subnet. So we got the 2 hosts per subnet. So considering your answer above, which subnet must meet the required number of minimum host address? So minimum host address, we knew that our host address are 50, right? So our host address are 50. 50 host address, IP host 50 and 40. So bear in mind that you need to consider from the answer the required number of minimum host address. Therefore, we knew that over 25 and over 26 is the answer for this question. 128 hosts and also 64 hosts or 62 hosts. Next question, we have considering your answer above, which subnet must meet the required number of minimum host address is over 25 and 26. Considering your answer above, which subnet must meet the minimum number of subnet required? So minimum subnet number is required. So the answer is over 26, 27, 28, 29, 30 will give the required number of subnet. So 26, 27, 29, 26 for subnet, 8 subnet, 16 subnet, 32 subnet, and 64 subnet. The subnet are in here have been there's 2 and 2 additional unused subnets. So because of that, the answer is this 26, 27, 28, 29, 30 will give the required number of the subnets. So considering the answer above, which subnet must meet both the required minimum number of hosts and the minimum number of subnet required? So we have hosts in here is 50 and 40. So the question is, which subnet must both the required minimum number of hosts and the minimum number of subnet required? So the answer is over 26 because it is give you 4 subnets. We see back at 26. 26 we have 4 subnet and 64 hosts per subnet. So it is 62 because 64 we minus it by 2, right, to get per subnet. So we get 62 per subnet, which is greater than 50 hosts required for the first subnet. Because of that, the answer is over 26. Alright, for the next question, 1J, when you have determine which subnet must meet all of the stated network requirements, derive each of the subnets, list the subnets from first to last in the table. Remember that the first subnet is 192.168.0.0 with the chosen subnet mask. Okay, for 192.168.0.0 is the chosen subnet mask. So back to the question. So 192.168.0.0 is over 24, but we would not using over 24. Instead, we using over 26. So if the prefix is over 26 for the first, then the others will be 26. So 192.168.0.0 the subnet mask is 255.255.255.192. So the prefix and the subnet mask over 26, the prefix and subnet mask is 192. So all the others, all the others is same, but the differences is in the subnet address. So 192.168.0.0, the next of the subnet address we must plus 64 at behind of it. So 64 for the next 64 plus another 64 is 128, and next 128 plus 64 is 192. So for the next question, my friend will solve it.
Okay, next question is part 1 step 2. Okay, for this question we must know first usable IP address, last usable IP address, and broadcast address before we can continue to fill in this box, this table. Okay, first usable IP address is one number from this network address. This network address we can get from the previous question. Here, let's subnet address. Network address is first usable IP address is one value from this network address. For example, 162.1.01, and last usable IP address is one number before the broadcast address. A broadcast address is one number before the network address. Here, next network address 63, and this is 62, and so on. We must fill in all the table first before we can continue for the next table. Okay. We must fill in all the this table first. After finish fill all the this table. After finish table, we can move to this table based on this question. Okay. A. Assign the first subnet to LAN A. First, use the first host address for the customer router interface and connect to LAN A switch. Okay. Use the first usable IP address here. Copy and paste interface customer router. Subnet mask is here. All subnet is same. Okay. Next question. Second, use the second host address for the LAN A switch. Make sure to assign default gateway address for the switch. Okay, for this question, we use this IP address, but once we change to 2, and so the path is same. The default gateway is IP address. This IP address. Okay. Third, use the last host address for the PCA. Make sure to assign a default gateway address for the PC. Okay, for this question, we use last usable IP address. Copy and paste to PCA, and subnet is same. The default gateway is same with the LAN A switch. Okay, finish the B question and move to A question, move to B question. Assign the second subnet to LAN B. Okay, first use the first host address for the customer router interface connected to the LAN B switch. Okay, we use the second network address, the first usable IP address is here, and subnet is same. Okay, we move to next question. Second, use the second host address for the LAN B switch. Make sure to assign a default gateway address for the switch. Okay, for this question, same like the previous step, LAN A switch, use this, but 65 change to 66, and the subnet is same. Also, the default gateway is same like customer router here, IP address here. Okay, next we move to third last question. Use the last host address for the PCB. Make sure to assign a default gateway address for the PC. Okay, next PCB. IP address is last usable IP address for the second new address. Copy, paste, and subnet is same. So the gateway is IP address for the second interface like this. Copy and paste. Okay, we finish this question. We can move to next question. The next question is explained by other people. Okay, that's all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Daniel Ashraf bin Shams Satalia. Right now I'm gonna explain to you part 2, step 2. Configure the two customer LAN switches. Configure the IP addresses on interface VLAN 1 on the two customer LAN switches. Make sure to configure the correct default gateway on each switch. Okay, for this one, for the step 2, you have to go to the Cisco packet tracer, okay, and click to the LAN A switch and press the CLI. And when the CLI, you have to insert this thing. Okay, when you enter the CLI, at the LAN A, remember to press the LAN A switch. Okay, and after you press the LAN A switch, go to the CLI, and then you have to enter this thing. Okay, first you need to type the switch enable, and then the configure term. And after you have entered the configure term, you have to, and based on the addressing table, you have to look at the devices. So we are doing the LAN A switch, okay, and the interface say it's VLAN 1. So it's int VLAN 1, interface VLAN 1, and after that you have to enter the IP address and subnet mask. As you can see here, 192.168.02.0.2 255.255.255.192. As you can see, I already type it here, and then you have to type it the no shutdown, exit, and then you have to input the default gateway 192.168.0.1, and remember to type the host name. As you can see, the host name here at the device is LAN A. Okay, remember that. Okay, for the LAN B switch is the same thing. It's the same thing. You have to go here and go to the CLI, and after you go to the CLI, you have to enter the exactly same thing for um, LAN B switch. Okay, and for the LAN B switch, as you can see, for the LAN B switch, still the same enable configure term and int VLAN 1. As you can see here, int VLAN 1. And after int VLAN 1, you have to input the IP address and the subnet mask. For the LAN B switch, as you can see, it's 192.168.0.255.255.255.192, and then no shutdown, exit, and you have to enter the default gateway. So for the gateway for LAN B switch is 19 oh, no 192.168.0.65. Okay, so we already done for the part 2 step 2. So we are going to the part 2 step 3. Okay, for the part 2 step 3, you have to go to the PCA and go to the desktop and IP configuration. Okay, as you can see here, okay, the IP here, you have to look again at the addressing table again, and you have to enter the PC. For the PCA, the IP address is 192.168.62, and then the subnet mask is 255.255.255.192, and then the default gateway, and then done. Okay, for the PCB, it's the same thing. You have to go to the desktop IP configuration, and you have to input what the addressing table say. For the PCB, yep, 192.168.0.126, and the subnet mask is 255.255.255.192, and the default gateway is 192.168.0.126. 192.0.65. Okay, that's all from me. Thank you.
Okay, now for the Cisco Packet Tracer explanation, I will, if you want to have a peer-to-peer network, the first thing you need to do is you need to set up a consumer PCs first, the consumer part. Such as example, this one name PCA, this one is PCB. Both of them is connected to their own switch. Here, this is LAN A switch, and this is LAN B switch. And all the components here is connected to the power brick here. Both of them is using the same router, as you can see here. Okay, now for the internet service provider part. The ISP also has their own router here and their own switch. And the important thing for the ISP is their own server, which is connected to their switch. Okay, that's all for the physical mode of exploration. Now I want to show you the logical mode. Okay, the PCA is connected to the both PCA and PCB connected to their switch using the straight through cable, which is using the type of twisted pair of copper wire cable. And then their switch to connect to their router also using a straight through cable, still using the copper cable. Okay, and for the customer router and the ISP router, which has a long route, and you need to maintain the fast internet. They are using a serial DTE cable, which is DTE stands for Data Terminal Equipment. Use DCE, DTE. Betul lah. For the logical mode, I want to show you both PCA and PCB connected to their own switch, which is different switch, using a straight through cable, which is the type of twisted pair of copper wire, and their switch connected to their customer router using straight through cable also. Okay, for the different cable used to connect the customer router and the ISP router, which is they are using the DTE serial cable. What is DTE? DTE stands for Data Terminal Equipment. So DTE is typically either a dumb terminal or the serial port on a computer or workstation. Okay, that's for the customer router and the ISP router. For the ISP router and the ISP switch, still they are using the straight through cable and their workstation on the ISP network and their server. Both they are using the straight through cable. Okay, now the first thing you need to do is to configure the LAN switch A, which I already configured it. Okay, it's already done. And the first thing you need to check is whether the PC is connected or not. It's like this. So the IP address already there. And if you want to know furthermore about the IP address, you need to click on the PCA. and click on the command prompt. And for the PCA, I already do it. You need to type ipconfig. Okay, now it will pop up this one and shows you the IPv4 address, which is 192.168.0.62, and for the subnet mask is 255.255.255.192. The default gateway, which is the router, is 192.168.0.0. And for if you want to check the connection between your PC and the router to the backend at the ISP, what you need to do is you need to type ping, P-I-N-G, and the IPv4 address 192.168.0.62. And it shows you pinging with 32 byte of data. Okay, this only need 1 millisecond from 32 byte. And the next one is the 3 millisecond and 1 millisecond and 2 millisecond. So packet send 4, receive 4, loss 0, which is the effectiveness of the router. Okay, now what I need to show you is how you want to pop up that thing. Okay, I will use it on the PCB. First, you need to ipconfig. Okay, and it shows you the IPv4 address 192.168.0.126, and the PCB subnet mask is 255.255.255.192, and the default gateway is 192.168.0.65, which is the default gateway for the switch. And now I want to show you their ping. Enter. And see, they're pinging. So PCB takes 5 milliseconds, which is slower than PCA. The second one is 13 milliseconds, 12 milliseconds, and 8 milliseconds. They are a bit slower, but the packet send 4 and receive 4 and loss 0, which is also good. But the approximate round time in a millisecond, the minimum is 5 milliseconds. The highest is 13 milliseconds, and average plus minus is 9 milliseconds. So you can close this. You can continue. So if you want to see the gigabit internet. So this one is for the LAN switch A, gigabit internet 0/0, and this one is gigabit internet 0/1 for the router and switch B. So if you want to know that, you can just hover on the line here. Yeah, fast connection internet 0.2 and gigabit internet 0.0. This one also fast internet 0.2, 0/2, and gigabit internet 0/1. Okay. Now I want to show you the difference between the subnet mask and the IP address. Okay. First, we open the PCA and fast internet, and then PCB, fast internet, and then the customer router. Okay, put this to and show you. Okay, so PCA, the difference between the IP address and the subnet mask is each of these components is connected to the network has a unique ID, which is the IP address. You can see it is different between each other. And the subnet mask is the same because it is controlled by the customer router here. It is connected to the ISP router. Okay, now show you guys. If you want to check the current situation of the connection, you can hover here and a while. Okay, and then it will show you the Vlan. So, okay, the customer router will check the connection between the switch there, the two up there, and the connection between the customer router and the ISP router at the serial 0/1/0. It shows you. Yeah, it is also at the ISP router. It is also shown the connection between the customer router and the ISP router at serial 0/1/0. And the gigabit internet 0/0, it is connection between the ISP router and the ISP switch. Okay. I think that's conclude my explanation at the Cisco Packet Tracer.
Hi, my name is Daniel and I will explain about part 3. There's a test and troubleshoot the network. Okay, let's go. Okay, for the first question, determine if PCA can communicate with the default gateway. Do you get a reply? Okay, we go to the PCA and command prompt IB config to verify the IP address. This is a default gateway IP2 to its default gateway 01 success. Okay, do you get a reply? Yes. Okay, for the second question is, okay, we go to PCB command prompt and IP config, and this is the default gateway 065 with a 168.065. Do you get a reply? Yes. Success. Okay, for the question C, okay, we go to the PCA and ping the IP address of the PCB when I do 160 on PCB is 126. It's 126. Success. Do you get a reply? Yes. Okay. That's it for me. Thank you.
So our resources get from YouTube, Google, Cisco, and we also Google Meet with a teacher lecturers that help us, and also friends that also help us in this presentation. So thank you very much. If you have any question, don't be shy to comment downside below, and also we surely reply for you. And like, subscribe, and share with other friends so people will know and like this. So remember, stay safe, wear a mask, and also social distancing in this pandemic. I hope that you guys can stay healthy and get a vaccine. So also thank you to our lecturer. Thank you to our lecturer for this semester. I hope you stay healthy and have a good day and have a great Also, thank you very much from us. Bye-bye.